So first of all, our consumer is a consumer that is going to be at least once. Because when we don't set anything regarding the offset commits in here, by default, there's going to be something called an auto commit of the offsets. And this is something that we don't control unless we set disabled. And basically that means that if you follow this kind of structure, it's going to be at least once. Let's look at what happens when we consume records. So when we consume records and we get a records here, we read all of them into a for loop, and we're going to create an index request and place the value in there. And then we're going to request the data. So what happens is that if this gets run twice for the same record value, it seems like the same tweet will be inserting 2 times. And that's quite bad. The reason is because every time we insert data, we get a new ID. As you can see here, the new IDs we get a new ID, and this ID is going to be new every time. What we want is to make sure it's idempotent. And for making it idempotent, we need to tell Elasticsearch which ID to use, not just a random one, but we need to find an ID to use to make it idempotent. So here, we need to add an ID argument, and we have to figure out how we make that ID appear. So this is to make our consumer idempotent. This way, if we have a predictable way of creating this ID, then we'll be sure that even if we run this index request twice, the data will not be appearing twice into Elasticsearch. It will just be overwritten for that specific ID. Now there's 2 strategies for creating IDs, okay? So 2 strategies. There's going to be the first one, and the first one is what I call a Kafka generic ID. And so a Kafka generic ID is going to be string ID equals, and we can take the record topic plus the record partition plus the record offset. And the combination of these 3 things is basically going to be an ID, and it's going to be unique. Yes, because each message within Kafka has a topic, a partition, and an offset. And that is how you identify a message in Kafka. So if we wanted to make this really look really nice, we'll do this, and then we'll add an underscore. So this is quite nice because here we have the guarantee using this Kafka generic ID that now if we reprocess the same message twice, so it will have twice the same topic, twice the same partition, twice the same offset, and therefore it'll be the same ID. And so because we included ID here, then things will be idempotent. So this is quite nice. But we can probably do better. We can probably, indeed, do an ID that is going to be specific for our stream. So this is a generic ID in case you can't find an ID. But we can find a Twitter feed specific ID. And it's just another strategy. So basically, we need to do string ID equals, and we need to get an ID from there. So let's have a look again at some data. So let's take this one right here and do a get on /Twitter/tweets/this ID. And so if we look at the payload of source, we can see that there is an ID field or ID string field in our source, which identifies uniquely that tweet. And so that's something we could use as the ID in Elasticsearch. So we want to extract that ID string from our Elasticsearch message. So we go back right here. And so we basically need to extract it from the record value. So how do we read a JSON? So we need to do extract ID from tweet of this. Now let's go ahead and create that function. So I'll go in the bottom or right here and say private static string extract ID from tweet. It takes a string, which is a tweet JSON, and it needs to return something that will be the ID. For this, we can use the JSON library. So let's go ahead and import it. So we'll go online and do Java Maven JSON. And this is basically a JSON library by Google. So I click on it, go to Maven, take 285, this sounds great, and copy this entire dependency back into our pom.xml file. So let's just go and find the pom.xml file. Here it is, copy it at the bottom, and import the dependency. Now, if we go back in here, we can start using the JSON library to find our field. So the first thing we have to do is, what we do then is create a JSON parser instance So we'll call this JSON parser. And this is a new JSON parser. And we can make this private and static to be accessible. And here we'll use a JSON parser. So we'll say JSON parser dot parse, and we can parse a string. So we'll parse the tweet JSON. Then we can do get as JSON object dot get, and we can pass the string ID underscore string, and we get the ID string straight from our Kafka course, which is right here, ID string. And finally, we'll do dot get as string. And this is what we want to return. So we want to return the ID from there. So you can have many ways. You could use Jackson library or other libraries, but I choose JSON because I think it's quite simple. So here we go. We parse the tweets and we get the ID string, and we'll get it as string. So now this is how we get our ID. We get string ID equals extract ID from tweet, record.value. Then we'll create our index request, pass in the ID we just extracted, and finally get the index response and log. We can log index response dot get ID. Now let's have a look and see if that worked. So we'll start our Elasticsearch consumer. And as you can see in the bottom, now the IDs that are being returned are the IDs of the tweet. If I stop this, okay, I've just stopped it, and we look at this ID, which ends in 28, I'll go into my interactive console, click on run, and then here we see that our tweet that ends in 28 is also the ID of our Elasticsearch, Elasticsearch ID, underscore ID. So here, this is perfect. We've set an Elasticsearch ID on our own. And now to test whether or not it's idempotent, well, because I haven't committed my offset yet, if I rerun this code, I can see this. I should be able to see the same sequence, 63, 76, 28, etc., etc. So let's have a look and run this again. And yes, we see 63, 76, 28 as the IDs. And so basically my data is being reinserted, but it's not inserted as a duplicate anymore because we have forced an ID to be the ID of the tweets. And so this is how you make a consumer idempotent. Two strategies: either extract a Kafka generic ID or extract an ID specific from your value and use this in your index request in Elasticsearch. And this concept could be applied to anything, to a database, to a file system, etc., etc. So you're free to think about a way to make your request idempotent. So I hope that was helpful, and I will see you in the next lecture.